The next algorithm which I'm going to teach you is QuickSort. Okay, QuickSort algorithm. Okay, the first thing is to understand here is, because of the name quick, it doesn't mean that the algorithm is faster. Okay, so it's just a name. Okay, so this algorithm is not quicker when compared to insertion sort and merge sort stuff. Okay, but still this is called as quick sort. Okay, due to some reasons. All right, so here again the idea here is to remember the pivot element or pivot element. Okay, there is a particular element called pivot element in your array which you have to choose. So you have to choose the pivot element. Okay, and you can choose any element as pivot. If you are looking for any multiple choice questions, please remember this point. You can look for any element. Okay, you can choose any element as pivot, right? You can choose the middle element. Either you can choose the first element, last element, or middle element, and even any random element from the array. Let's say my array is 1 2 5 7 9. You can choose 2 as your pivot element, 9 as your pivot element, and so on. Okay, you can choose any element as the pivot element, right? What do you mean by pivot element? And we'll perform the comparison with the help of this pivot element. Okay, that's why it's called as pivot element, right? Okay, that's the idea, guys. I hope you understood this idea. Let's move on. Okay, let's take an example. Let's say these are my array elements. Say 40, 90, 61, 5, 13, 11, 21, 45, then 50. Alright, so these are my array elements. So I have a long list of arrays. Okay, so what I have to do here is I have to choose one element as pivot element, right? Okay, let me choose 40 as my pivot element. Okay, or pivot element, whatever you call, but I'll choose 40, right? So that's the opinion here. All right, so the next idea here is we have to use two loops. Okay, so one loop should iterate from the start of the array and another loop should iterate from the end of the array, right? Okay, and what should we do using the loop is, uh, you should look for an while you are iterating from the left of the array, you should look for an element which is greater than the pivot element, and while you are iterating from the right of the array, you have to look for an element which is lesser than the pivot element again, right? The pivot element you have chosen is 40. Why we are doing this? To make sure that this 40 is sorted, right? What do you mean by 40 is sorted? You have to have 40 here. The elements which are right to 40 should be greater, and the elements which are left to 40 should be smaller than 40, right? That's what we mean by sorting an element. We have seen this. We have seen this in the quick sort, I mean insertion sort algorithm, right? So let me not teach you this again, right? So here the idea here is you have to use two loops. Okay, so this may be having a counter variable, say I. This may have j, which is the iterator, right? So you have to iterate from both the side of the array, right? So let's check. While iterating from left side of the array, I have to look for a element greater than 40. Say 90 is definitely greater than 40, right? Right. Okay, so 90 is definitely greater than 40. So and if I check from this side, I have 50. That is not greater than, that is not smaller than 40. Understand? While you are searching from the end of the array, you have to look for an element which is greater than which is smaller than 40. Okay, which is smaller than 40, and while you are searching from the left side of the array, you have to look for an element which is greater than 40. So here it is greater, here it is smaller, right? Don't confuse. Okay, all right. So yes, 50 is not lesser than 40, which is my pivot, so I should not choose 50. 45 is not greater than 40, I mean lesser than 40. 25 is definitely, 21 is definitely lesser than 40, right? So I have chosen two elements. from the left of the array I have chosen 90, which is greater than 40. Okay, 90 is greater than 40, and from the right side of the array I have chosen one element, say 21, which is lesser than 40, right? So you have to use this technique. Okay, what you have to do now here is you just have to swap it. That's it. You just have to swap the positions of 21 and 90, right? So what you have to do here is you have to swap the positions of 21 and 90. So let me do that. Okay, so 21 goes here, 90 comes here, right? So I have swapped it. Okay, super. I'll erase this also. Let me not confuse you, right? All right, so after doing this, again, remember the position of I and j. My I is here and my j is here, right? So look for another element here. 61 is greater than 40. 61 is definitely greater than 40, so fix that element. Here if you look for another element, 11 is definitely lesser than 40, so here you have to choose the lesser element, guys. Here you have to choose a greater element than 40, right? So please remember this, right? So 61 is greater than 40, 11 is lesser than 40, so swap those elements. Okay, right? Swap those elements. Very simple, right? I'll swap those elements, 11 and 61. Here I'll get 11, here I'll get 61. That's it, right? So after that, what I have to do, I have to remember the position, right? So my I is here, my j is here. Okay, and if I check 5 is not, if I go and check 5 is not greater than 40, I am checking from the left, so 5 is not greater than 40, I can't choose 5. So let me take out, I can't choose 5, and 13 is not greater than 40, so I can't choose 13. 61, I think it is greater than 40, but meanwhile I would iterate with j also, right? Hold on. So j would come here, so j would be 13, which is obviously lesser than 40, and I would be 61, which is greater than 40, right? So what I have found here is j goes greater than I. I mean, j is already beyond I. Okay, you can see I is iterating from the left hand of the array, j is iterating from the right side of the array, and j exceeds I. Okay, j have come here and I have gone here, right? So j exceeds I. You can see j is we have chosen 13 and I goes 61, right? So j becomes greater than I, of course. J becomes greater than I. So if this is the case, okay, if this is the case, what you supposed to do here is you have to stop the iteration there. So j becomes greater than I. So if this is the position of j now, and this is the position of I. So when j goes left to I, that's it. When j goes left to I, you have to stop the process here, and that is the position of your pivot element. What I mean is that is the position of your pivot element. That means you have to swap those elements. You have to put 40 here, right? You have to put 40 here. So what I'll get here is 13, 21, 11, 5, 40, 61, 90, 45, 50. Here you can see that we are having 40, that is our pivot element, and you can see that the elements which are lesser than 40 are lesser than 40. Okay, the elements which are left to 40 are lesser than 40, and the elements which are right to 40 are greater than 40, which means that 40 is sorted. Hooray! We have sorted the pivot element, right? So that's how it goes on. Okay, it's very easy, guys. You have to choose a pivot element, and you have to use two loops to make comparisons. Okay, you have to start from left of the array, and you have to find an element which is greater than the pivot element. It's not 21. It is greater than the pivot element. Choose that element, and you have to start from another end of the array, and you have to choose an element which is lesser than the pivot element, right? And you have to swap those elements. That's it. You have to swap those elements, and you have to continue the process until j goes beyond I, right? So when you are iterating from this position, that is I. you are iterating from this side, that is j. One At one point they will encounter, right? At one point I will be equal to j, and another point j goes beyond I. That means j comes here and I goes here. At that particular point, you have to stop the process and you have to identify the position of j. The position of j at that particular point is your pivot position, and that is your pivot position, right? And you have to make a swapping there, right? I hope it is not confusing. It's very easy. So that is the when j go, remembering the j goes greater than I whenever it happens, then the position of j is your pivot position. Okay, it's your pivot position, and you have to make the last swapping. And yet the array is not sorted. We have sorted only the pivot element, right? Because here you can see the array is not at all sorted. You have to sort this portion, you have to sort this portion separately. But you can very well say that the 40 is the element that is sorted. That is the pivot element, right? Super. So next, let's sort this array, and for this array also you have to repeat the same process, guys. What is the process? You have to choose again a pivot element. Let's say I'm choosing 21 as my pivot element, right? If I choose 21, then I have to look for an element. So I have to look for an element greater than 21 when I am iterating from the right side of the array, and I have to look for an element which is lesser than 21. I have to by iterating from the right side of the array. So I have to repeat the same process, so that I will get this side of the array sorted, and I have to repeat the same process for this side of the array also. So yeah, that's how it works, guys. Okay, that's how it works. And yeah, I think that's all about quick sort algorithm. So you have to repeat the same process. The process is very simple. You have to choose a pivot element first, use two loops, start from left side of the array using I, start from right side of the array using j, choose element less greater than the pivot element, greater than pivot, choose element lesser than pivot, okay, and swap it. Okay, swap it. That's it, right? Lesser than pivot and swap it. After swapping, greater than pivot and lesser than pivot, after swapping, at one point when j goes beyond I, that is the position of your pivot element. Position of pivot element. So swap the pivot element there. Pivot element, swap the pivot element there. After that, the array gets broken into some pieces. So repeat the same process for that particular set of array alone, right? So that's how quicksort algorithm works. So I hope you have understood this. Thanks a lot, guys.